Ah, so first of all, thanks a lot for the entire team to actually invite me to speak in this meetup. And I'll start with the small introduction. My name is Santosh Yadav, and I'm one of the Google developer expert for Angular from India. I'm in Pune, in case you know Mumbai. It's nearby, uh, and I'm also one of the writer for indep.dev, and I also mentor for .NET Tricks. So this talk is a lot about optimizing an Angular application, and these are the experiments which I did in my own app. So when I joined my new organization, I figured out they are really struggling with the bundle size. The initial bundle size was around 9 MB, and of course I don't like large apps, so I decided to do some experiments and then how we can actually reduce the bundle size, and this talk is all about it. So in case you want to connect with me, you can follow me on Twitter. If you are on LinkedIn, you can send me a connection request there. And you can also find about me on santoshyadav.dev, which is my portfolio. You will be able to find my YouTube channel. You will be able to find all the uh, social media links as well. So let's go ahead and get started. It will be really short. So let's see what we have next. Okay. So the prerequisite is, of course, this is an Angular meetup. So I'm sure everyone knows about Angular. In my application, I was using Angular Materials. So this is optional, and we were using custom themes. So again, the knowledge is really optional. This was my setup. So the first thing, and I think the low hanging fruit which we have whenever you want to optimize an Angular application is lazy loading, right? So in our application, there was no lazy loaded modules. So the first thing which we decided to do is we decided to split our Angular application, and we decided to implement lazy loading because there were many modules. I mean, not one. I think there were 4 to 5 modules which could be lazy loaded, but I think the development team didn't actually bother to do that earlier. But of course, it was a bottleneck, and we decided, okay, let's go ahead and see how much we can save, because initial bundle size was around 9 MB in production build, and of course we had a server where zip was enabled, but still it was really huge. So after lazy loading, we could see there is some improvement. We could see that from 9 MB, the initial bundle size came around 6 MB, which was really huge because uh, of course we are saving. Even a single byte matters on web, right? So how lazy loading helps? So using lazy loaded modules, what you can do is you can have separate feature bundles, and you can also load your bundles on demand. So that's a really cool thing to do. You don't have to actually go ahead and download entire code at once your user accesses your website. So you can actually delay the loading, and the most important thing, you have to actually serve less code on first serve. So there are a few things which you can do in case you think that you don't have to worry about when your lazy loaded module is getting downloaded. So what you can do is you can also configure preloading for your application. So there are a few there are a lot of solutions which are available on the internet, but there are a few which is widely used. So one is Nginx Quicklink, which is created by Minko, where you can actually the way it works is like it will check if your internet connection is stable and the user is idle, right? That's the important thing to do. So in case user is ideal, he can your module will be actually downloaded whenever there is a free bandwidth which is available. Then we have Guest Parser, which is again created by Minko and the other team members. So it uses Google Analytics. So it first uses Google Analytics to generate the data that how many users are using which route, and based on that analytics, it will try to download your lazy loaded module. So it's like, in case you have Google Analytics, I think I would say go ahead and use Guest Parser. That would be great. So this is about lazy loaded module. The next thing which I did is this was an experiment which I tried in my application. We had two huge shared modules actually. One was related to your material. I'm sure you might have seen Angular materials code, and you can see there is a file where you have all the modules imported into a single file. So that was one, and another one was where we used to actually import all the different components, register all the different components which we had in our application, and then we were using that shared module everywhere. So I was like, okay, I think there is something wrong. So first I decided to do a small POC to prove them that we can actually save some bundle size by avoiding this shared module. So this is what I did. I created a new application, and that application was just using NGNew, right? So 382 KB. And then I decided to add few modules. So it went about around 423 KB. And this is the code. I'm sure everyone knows about it if you have seen Angular material docs, right? So we have all the modules imported here. So now what I did is I added few more modules, and the final size of my application was 639 KB. Then I decided to implement lazy loading. And after implementing lazy loading, the size went up to 705 KB. So I was like, okay, now let me do one more thing. Let me just remove this shared module which we have in our application. I decided to remove it and then just use the modules wherever it is required. For example, we had in my POC, I had 3 modules. So I just removed everything and then just use for example, if I'm using just card module in one of the module, I just use card module, not the entire shared module which we had. So I could see there is, okay, so it came down to 64 KB. And then I went to the team that, okay, this is something which I can see in my POC. So let's go ahead and do that in our application. And then we could see that, okay, now the bundle size has reduced again. We decided to adjust some modules as well because they were actually not getting used. And then after we removed our shared module, we actually came to know about these modules are not getting used even. And then we can see, okay, we saved few more bundle size. So finally our bundle size came below 5.5 MB. I'm talking about the initial bundle size. And then I decided to check what's in my bundle, why it is so large. So I actually attended a talk by Igor at NGConf this year, and then he talked about a tool called Source Map Explorer. And using Source Map Explorer, you can actually go ahead and see what's in your bundle size or what's in your application. So I decided to build a tool on top of it, which is the NGX Builder/analyze. You can just use ngadd and run this command at the NGX Builder/analyze. It will configure this bundle analyzer for you, and then you can run this command ng-run project name and then analyze. And this is how I can also configure it. I just added an analyze command in my package.json, and then I can use it. And it gives you data like this. So you can see who is responsible for adding some of the code in your final bundle size. I could see, okay, my SRC is like 284 KB. This is something coming from Node modules, Angular, and then there might be material as well. So you can see material is responsible for 224 KB. And then there was a strange thing which happened. So I was like, 96 KB for a single module is really huge. And then I figured out, okay, there were some issues. The way we used or the way we created our Angular components, there was some problem. So we could figure out only after using this tool that, okay, what's in my bundle size. And it also helped us to actually split our modules as well, because we could see a lot of modules which are not required on startup are still on my the initial bundle. So we removed everything, and right now you can see, okay, this application with 3 modules and Angular material and custom theme is around 1007 KB. And last time I did a talk where I just tried 2 things. I tried to remove a shared module, and I did lazy loading. And this application right now, which we can see, came around 800 KB. I mean, I could simply use these 2 techniques and save 200 KB. So that was really good improvement. Okay, so you can use this tool, but again, there is one more important thing when you work in your application. This is something which you have to do repeatedly. It's not like you have to do it once. It's continuous process, right? Evolving your application is that it's a continuous process. So in Angular 8, I think they added this feature where you can define the budgets. So in my application, the previous team actually added the budget size was around 10 MB. So we never used to get any error, even if my application grows beyond some size, because of course my application size was 9 MB earlier, but I could see, okay, it was already set to 10 MB, so it will never fail, even if it increases by a KB or let's say a few more KBs. So what I decided to do is, while doing my entire optimization stuff, I decided to set the budget size specifically. So finally I could see, okay, after all the optimization, I can see the initial bundle size, which was 9 MB, came down to 3.5 MB, which was like 6. We are using actually we are saving 6 MB on the startup. So what I decided to do is I decided to set the initial bundle size, which was around 3.6 MB. If I add few more files, so it was around 3.6 MB. So next time it actually happened when one of the developers who was working on one of the feature, after he compiled everything, the bundle size went above 4 MB. So there was increase of like 500 KB, and the build failed. So he decided to actually connect with me and see what's wrong. And then we figured out, okay, there are some wrong imports which happened, and due to which the application size grew by 500 KB. And it's really good feature because, of course, whenever your application breaks, rather than actually increasing the budget size, you can actually discuss why budget size was increased, what made it happen. In case it's like 1 MB or 1 KB or 2 KB, it's like, it's okay, it happens. But in case it's like drastic change, you can actually go ahead and see what's happening in your application. Another thing was any component style, where you can define, okay, per component, how much CSS size or your component style size should be. By default, it's around 6 KB maximum, and maximum error is 10 KB. But once you use custom theme, I am sure it would be around 40 to 60 KB. In our application, it was beyond 90, I think beyond 50 to, okay. So there were a few modules where it was beyond 90 KB, but it was due to wrong imports. We figured out, okay, there are a few wrong imports or unused imports. I'm talking about the SCSS. So let me just show you some code. For example, yeah, I'll show you the dashboard. So if we have this SCSS file, you can see this SAS variable. We are not using anything from variable here, but we are still importing it. And if you remove it, you will see there are the application or component size will be reduced already, because this is something which is not reshakable. Of course, there are few techniques where you can actually remove unwanted CSS. I'm sure post CSS is really useful. Few people do use post CSS to remove unused CSS, but in case you don't want to do that, you have to actually work or see your code base again if there is something wrong. And yep, so I removed all the unused CSS SCSS imports. And there was other thing that in case I go to my themes, we have this SCSS material theme file. So at some places, somehow we actually imported this entire material theme file as well. I mean, of course, it is not required, but it was a mistake, and due to which actually my component style was beyond 100 KB. So that was really useful. We could actually figure that out by using this particular tool, Source Map Explorer. And there are multiple types of budgets we can set. So you have bundle size. So you can specify per bundle or specific bundle size, how much it should be. Initial bundle size, this is something which will be loaded on your first request. Scripts also, so you define scripts, right, inside your angular.json file. So you can define, okay, how much size should be for all the scripts inside my application. All is for the entire app. So in case you don't want to bother about all the other properties, you can just set it all. For example, let's say my application should not increase more than 4 MB. So I'll just set all. So let me just show you the settings as well. So I can go to angular.json. This is budgets. So I can just go ahead and say this is all, and that's it. So if my application goes beyond 5 MB, it will just break. And then there are a few more. You have any component style, where you can define the component style for each component. Any script, again, for it's like for any script, it should not go beyond this size. And any file. So this is something for any file. Any file should not go beyond, let's say, 100 KB. So this is something which you can set inside your application. Other thing which we had used Lodash. Of course, it's CommonJS module, right? So we should avoid using CommonJS module. Try to use ES modules. For example, if you're using Lodash already has something known as Lodash ES. Or if you're using Deep Dash also has ES module. So I replaced my Lodash with Lodash ES. And if you use Lodash, just go ahead and see this your application budget or your application this analysis. Run the source map explorer. You will find that Lodash adds around 600 KB. I'm not talking about gzipped, but it adds around 600 KB. And once we replaced that with Lodash ES, we could see we are actually using 3 to 4 functions, not more than that. And the application, the entire Lodash size came around 6 to 10 KB. which was like more than we used for 590 KB without doing much of effort, right? So avoid using CommonJS modules. And Angular 10 added a new good feature. I think this is really required. So a lot of developers don't care about what they're using. They just find a module and they start using it. So now in case you are creating a new application using Angular 10, or you migrate your application to Angular 10, you will start getting a warning. It won't break your application, but it will throw you a warning that you are trying to use CommonJS modules. In case you still go ahead and want to use that CommonJS modules, of course, there is a way. You can just go ahead and say allowed CommonJS dependencies to disable this warning. You have to set it inside your build options. So yeah, so this is build and this is optional. So you can set inside this option, you can just set a new property, allowed CommonJS dependencies, and you can define whatever packages which you are using. For example, if you are using Lodash and you still want to go ahead and use Lodash, you can just mention it's an array of string. Okay, use CDN to serve the assets. A lot of developers actually add assets file. I would suggest go ahead and use CDN maybe. I use Netlify, so I don't use CDN, but I mean, Netlify takes care of everything, so I don't have to worry about it. There are advantages, of course. So you have low network latency. Your files will be served faster. I'm sure everyone knows how CDN works, right? So it will just try to serve the resources from the nearby servers. So it's high availability and better analytics. So it knows from where your requests are coming, and it decreases the server load, right? So you don't have to actually put your assets in your main application where your application is deployed. Always use prod build. Of course, I don't have to tell this to everyone, but you already know, you all already know about it. So you have to always use prod build and use gzip minification if possible. So a lot of servers already provide gzip minification by default. For example, I use Netlify, so they already provide gzip minification. In case your server supports gzip minification, go ahead and use it. It's really great because in our case, our application size was around, including the lazy loaded modules, it was more than 6 MB, which is still large. So we tried to make it, right now it's around 5.9 MB because, as I said, right, the optimization is a process which is a continuous process. You don't have to, it's not like you did it once and then it's done. So we have around 5.8 MB from 9 MB, which is like, we reduced the bundle size around by 500 MB, 50%. So that's what we did. Now we are trying to reduce it more. But the server which we are using, we have gzip minification available. So the final bundle size, or the final what you can say, the final code which actually end user gets is around 800 KB. So it's not even an MB, including the lazy loaded chunks. So that's what gzip minification can do for you. And this source map explorer also comes with a flag. You can just pass a flag called -FN gzip, where it will show you how much code size or how much code you will be serving once gzip is enabled. So that's also, you can see it or propose the changes to your team, right? So in case we use gzip, this is the advantage you should get. So that's also possible using the gzip minification. And as I said, this will be really short, so I'm almost done. So this is references. As I said, I did 2 POCs before I actually try to implement everything in my application. Of course, I don't want to break an large enterprise application, otherwise I'll be kicked out of my job. So I did those POCs and I wrote about it. So you can just go to indep.dev and you can read about this 2 blog posts where I have given all the data as well. What was the size before I had started my POC, and what was the size after completing the POC. So it's available here on indep.dev. You can read about it. And yep, thank you. So that's all. In case you have any questions that are related to anything, you can just always ping me on Twitter, or you can just send me a DM on LinkedIn. Yep. Thank you.